Hello everyone, this video will show how to solve logarithmic equations involving exponents. Now let's go over this first example. If you notice, the equation that we have here has an exponent of 3/4. We are going to use the power property of logarithm to simplify this given expression. So this equation would come out. So the power property of logarithm is a property where the exponent that we have right here is going to go as the coefficient or in the front of the ln. So we have 3/4 ln of x. This is the power property of logarithm. And this is equal to ln of 8. So that we can solve for x here, we are going to isolate x by itself on one side. So what are we going to do is we will multiply the reciprocal of this fraction here so that we can get rid of this 3/4. If we do that, we can go ahead and cross out 4/4 and 3/3 so that we are left with. So the 4/3 and 3/4 get crossed out, so we're left with ln x on the left side. And this 4/3 can be placed in front of the ln, and that's ln of 8 here. So that we can go ahead and use power property of logarithm. This 4/3 can be placed as an exponent of 8. So our equation would come out. If you notice, both sides are equal, which means that their arguments are also equal, so that we can go ahead and set up as x is equal to 8 raised to the power 4/3. This expression that we have on the right side can still be simplified. We know that 8 is 2 raised to the power 3, and this whole thing is raised to the power 4/3, so that we can go ahead and cross out 3 and 3 here. So we're left with x equals 2 raised to the power 4. So 2 raised to the power 4 is 16. So our x is 16. So this is the value of x that will make this equation true. Now let's have another example. Looking at the equation that we have right here, we have two logarithmic terms that are added together, which means that we're going to use the product property of logarithm to simplify these two terms here. So our equation would come out. So what I did here was I multiplied the two arguments that we have here, since these two logarithmic terms are added together. And that is the product property of logarithm right there. Looking at the equation that we have right here, we can see that both sides of the equation are equal. Both have ln on them, and they both have argument as well. So that we can go ahead and say that these two arguments here are equal to each other. So we can go ahead and set up that equation down here. Since we wanted to have x by itself here, we are going to divide 4 from both sides. So we are left with x to the power 2/3 is equal to 16. Since we wanted to have x by itself here, we are going to exponentiate both sides. To do this, we are going to multiply the left side. We wanted the exponent of the x to be 1, so that it's x by itself. We're going to exponentiate this side by 3/2. If we do that on the left side, we're going to do that on the right side as well. So we're going to raise this up to a power of 3/2. If we do this, we can go ahead and cross out 2/2 and 3/3. So that means we are left with just x raised to the power 1 is equal to 16 raised to the power 3/2. We can still factor this out. We know that 16 can be expressed as 4 squared. So that's 4 squared, and that's 16 right there. And this is still raised to the power 3/2. So we can go ahead and cross out the 2 and the 2 here. So we're pretty much left with x is equal to 4 raised to the power 3. If we simplify this, this is x is equal to 64. So this is the value of x that will make this equation true. So that is how we solve logarithmic equations involving exponents.